let's start with the power rule. How to integrate an expression of the type ax plus b to the power of n. For example, how do I integrate, where here a and b are constants. So for example, how do I integrate function of the type two x minus 3 to the power of 4 with respect to x? You would be tempted to say that this is easy. I just need to expand 2x minus 3 to the power of 4 using binomial theorem and make repeated use of the power rule to make the to complete the integration. Well, it's fine as long as the power of the 2x minus 3 function is easy. How do you integrate a function of the type 2x minus 3 to the power of, say, 47 with respect to x? This is significantly tougher than integrating 2x minus 3 to the power of 4, right? So therefore, if you have a general rule, you can write down the result of either this or this very easily. All right. So that is where the standard result of integration of ax plus b to the power of n comes in. How? If I make the substitution, t equals ax plus b, where a and b are constants, then the derivative of t with respect to x equals a into derivative of x with respect to x plus derivative of b with respect to x. So dt equals a dx. Okay, so but you would say that ax plus b to the power of n does not have the a, right? It's just dx. Well, since a is a constant, we can always introduce the a, that is by multiplying and divide the integration by a, and 1 upon a stays outside because it has no part to play, and this a in the numerator, it gets multiplied with dx. So a multiplied by dx gives us dt, and ax plus b to the power of n can be written as t to the power of n, and so therefore ax plus b to the power of n dx equals t to the power of n dx by a. So that's 1 upon a t to the power of n plus 1 by n plus 1 plus the constant of integration. And so this becomes 1 upon a times ax plus b to the power of n plus 1 by n plus 1 plus the constant of integration. And so integration of any linear factor raised to the power of n will be given by 1 upon a times ax plus b to the power of n plus 1 by n plus 1 plus the constant of integration. Again, just like in the power rule, the normal power rule of standard integrals, n cannot be equal to minus 1. That is, you cannot integrate 1 upon ax plus b in this manner. There is a different formula for that. So apart from n equals minus 1, it can be done for any value of n. And so integration of ax plus b to the power of n equals 1 by a times ax plus b to the power of n plus 1 by n plus 1 plus the constant of integration. Next, 1 by ax plus b. Again, a and b are constants here. So again, we introduce the a. So you get a dx. And so therefore, integration of ax plus b, 1 by ax plus b equals 1 by a times integration of a by ax plus b times dx. But a is the integration of ax plus b. So we can write a dx as derivative of ax plus b, d of ax plus b upon ax plus b. So that gives us log of whatever the function is. So log of ax plus b plus the constant of integration. For example, if I want to integrate 7x plus 2 with respect to x. 1 upon 7x plus 2. So the value of this integration is 1 by 7 log 7x plus 2. Next, integration of say 1 by 5x plus 9 with respect to x equals 1 by 5 log of 5x plus 9 plus the constant of integration. Similarly, integration of 1 by 3x plus 5 with respect to x equals 1 by 3 log of 3x plus 5 plus the constant of integration, and so on. Let's look at the next standard result, which is integration of e to the power of ax plus b with respect to x. So again, introducing the a, we get the integration of e to the power ax plus b as 1 upon a e to the power ax plus b plus c.